Music topics. Connecting you with a variety of musical topics. This is Music Topics. Music Topics presents the first video in a series about post-tonal music theory. Post-tonal theory Video 1 objectives. We will discuss basic musical concepts which include pitches versus pitch class, enharmonic equivalence, octave equivalence, and basic principles of intervals in post-tonality. Let's familiarize ourselves with the pitch class space, or otherwise referred to as a clock. Each number on the clock is assigned a pitch that it's associated with, starting with C at 0 and going clockwise. With each increasing number, there is a pitch 1/2 step higher than precedes it. If you are new to post-tonal music theory, I encourage you to familiarize yourself with the clock and get real comfortable with it. I suggest that you memorize the numbers to pitches because this will eventually save you a lot of time. Think about 12 o'clock, 6 o'clock, 3 o'clock, and 9 o'clock. C, F sharp, D sharp, and A. You can easily figure out the rest of the positions. Over time, it will become commonplace. Pitch versus pitch class. In post-tonal theory, we place musical pitches into classes. Don't think too hard about what this means. When analyzing music that is not structured around a tonal center, there isn't any hierarchy to organize pitches around. Pitch class is the universal and normative terminology when reconciling musical pitches in post-tonal music theory. Look at the example. Let's plot this chromatic scale on the clock so you get a better understanding about what is meant about pitch class. The pitch C is pitch class 0. The pitches C sharp and D flat are both pitch class 1. The pitch D is pitch class 2. D sharp and E flat, pitch class 3. E, pitch class 4. F, pitch class 5. F sharp G flat, 6. G, 7. G sharp A flat, 8. A, 9. A sharp B flat, 10. And the pitch B is pitch class 11. Simple, right? With this new way of labeling pitches by pitch class, there are two important things to consider: octave equivalence and enharmonic equivalence. First, octave equivalence. Look at this example. In the first collection, we can see C4, C5, and C6. In post-tonal analytical techniques, including set theory, C1 through C infinity and beyond is just considered C. Since post-tonal music does not adhere to the standard tonal practices of harmony and voice leading, there is no need to be concerned with the octave. So all of those C's in the first collection is just pitch class 0. The second collection of pitches are all considered A, or pitch class 9. The third collection is F. All the F's together, every F, is pitch class 5. And the last collection is pitch class 4, E. Enharmonic equivalence. Generally speaking, enharmonic equivalence is almost the same as enharmonic pitches in tonal theory. In tonal theory, enharmonics are considered two separate notes that share the same sounding pitch, but in post-tonal theory, enharmonic relationships share the same pitch class. They're kind of just the same thing. C sharp and D flat are both 1. F sharp and G flat are both pitch class 6, and so on. Look at this short example. E is pitch class 4, A sharp is pitch class 10, A is 9, and B flat, like A sharp, is pitch class 10. Let's explore this a little further. This musical example addresses both octave and enharmonic equivalence in a couple of different ways. Notice the collection framed in red, and let's slowly plot the notes onto the clock while considering octave and enharmonic equivalence. B flat is pitch class 10, C is pitch class 0, B is pitch class 11, and A is pitch class 9. Now look at A sharp. A sharp and B flat share an enharmonic relationship, and since pitch class 10 on the clock has already been plotted for this collection, it's not necessary to do it again. The same goes for C flat. We've already plotted the B natural, which is an enharmonic of C flat. And for C, octave equivalence means we don't have to replot this one either. Pitch class 0 is already represented. Now look at the collection framed in green. Since we're plotting a new collection, octave and enharmonic equivalence does not carry over to the new collection, so you kind of clean slate it. B double flat is an enharmonic of A, so it is pitch class 9. C flat is an enharmonic of B, so it is pitch class 11. C natural is 0, D is 2, G flat is 6, C natural is already accounted for. The last E flat is pitch class 3. Intervals. Intervallic labeling in tonal theory has two descriptors. First, the distance between two notes, then it also tells us the sonic quality, such as major third, minor third, perfect fifth, major seventh, tritone, etc. Since post-tonal music does not adhere to the rules of tonality, these labels really don't matter. It doesn't matter if it's a major third or a minor third or a tritone. Look at the first example framed in red. What in tonal theory we call an octave, in post-tonal theory we just call 0. Since there is octave equivalence, there's really no such thing as an octave. So the distance between 0 and 0 is 0, so it's just 0. This first video was a basic introduction to post-tonal music theory. We talked about pitches versus pitch class, enharmonic equivalence, octave equivalence, and basic principles of intervals in post-tonality. Thank you for watching. Keep your eye out for video 2 of this series about post-tonal music theory. If you have not done so, please, please, please hit the subscribe button down below. See you next time on Music Topics.